All right, so domain modeling. So we want to model an application, and we've already done some of this, right? Well, we've done the hard work, right? We looked at use cases early on, right? We talked about how to represent a use case analysis represented using a UML class diagram, right? We talked about how to normalize it, how to remove redundancies, how to remove how to reify, right? How to convert it into something that can be actually implemented in a relational database. So we already went through a lot of the grunt work that we would need to do to structure our database correctly. Okay, so we've already done a lot of the modeling work. We would do the same exact work if we were modeling for Java, right? In a Java classes. But some of the decisions that we made were specific to modeling in relational databases. So, for instance, some of the things that can be readily implemented in a class diagram are not readily implementable in a relational database, right? So, for instance, there were certain cases where we had to reify, right? Where we had either association classes or we had a many-to-many relationship, right? And we replaced those with mapping tables, right? Or tables that had references to the original tables that were part of the association. Yes, right. So there were some concerns, some challenges of going from a conceptual data model represented in UML class diagram to a particular framework or a particular way of representing that data using relational databases. We have the same exact challenges if we want to do data modeling and map the same world, map it to a Java, into a Java world. Okay, so let's talk about a little bit some of those challenges when we're trying to map relational databases to a Java data model. Right? Again, there were challenges going from UML down to relational databases. Now we're going to try and map UML relational databases to a Java representation, and it's not trivial. Right? So first, let's talk about the things that are easy. Right? Let's talk about some of the things that are easy. Well, let's look at what we would like to have. This is what we would like to have. We would want to have some entry point into a database. Perhaps the database is called DB Student. Right? We're still using the same toy database that we've been using throughout the semester. You know, students, classes, courses, sections, enrollments, departments, and whatnot. Yes. So this is our DB student, and that the database should provide maybe a whole bunch of an API that would allow us to do all sorts of operations on the database, right? Find all the students, find all the sections, find all the enrollments, find all the courses, give me all the departments, right? Given a student, give me all the departments for that student, give me all the enrollments for a particular student, right? So this DB database should provide a model. Right, a model that allows us to interact with this data representation. Yes, so for instance, if we ask for the students, we would get some collections or a list of collections that will allow us to treat or interact with the database with the students at a very high level, right, at the object-oriented world. Right, so somehow the conversion between from the low-level relational database representation would be somehow mapped to a much higher level representation in an object-oriented world. We would be able to iterate over it, and we have getters and setters that will allow us to interact and retrieve data for each one of these instances. Right? There would be no rows. Right? This would be a little array or collection or list of users of students. Okay, so for instance, let's look at some of the challenges of how we would do this. What would we have to consider? So here's an example of what we could do or to model a student. We know a student has a student ID. We know that it's somehow related to a department. We know that students can be enrolled in sections, right? So that has some associations with other things in the database. Correct? In the relational database, association that we had was a student having a foreign key to its department. That's the only time that a student had any relationship with anyone, right? All the other relationships were from the enrollment, for instance. The enrollment referenced a student, correct? So that we knew that a particular student might be enrolled in a particular section. But the student didn't know. Right? There was nothing in the information in the student that would give us any clue that that student was in any section. Only when you looked at the enrollment table, then you knew that this particular student was in this particular section. Make sense? Right? Now, bring that to Java, though. Right? If you bring it to Java, you want to be able to answer the same things that you wanted to answer at the relational database level. In a relational database level, you could answer what student is in what section by joining the student and the enrollment in the section. Right? That query allowed you to navigate from students to sections to enrollments. Right? Well, you want to be able to answer those same exact questions, but from the Java world. Right? So if you're looking at a particular student, you have an instance of a student, something that would be very, very common that you'd like to ask, given this student, give me the department that this student belongs to. So it would be very, very common to have a function such as get major. And that would give you an instance of the department that this student is enrolled in. Or you like to be able to ask, well, given this instance of a student, give me the enrollments for this particular student. That's very reasonable, right? That if I have an instance of a student, again, from Java, it would be a very common thing to do is ask the enrollments. Or what else? Or change the major. Okay, but so even though this is very reasonable. Okay, even though this is very reasonable from a Java's point of view, we need to think about the implications of needing to implement something like this. What is the implication of implementing get enrollments, right, or getting major? What does that mean? Does that mean that if I retrieve a user or student instance, sorry, how do I say go away and don't bother me anymore? Okay. What does this mean? If I want a user instance, presumably this user instance maps to a particular record in the student table. Make sense? But the student table doesn't have any data department information. The student table doesn't have the student record doesn't have any enrollment information. The only way that I would retrieve any of that is if I join with the department table or I join with the enrollment table. But Java doesn't know anything about this, right? It just wants to have this object instances, right? So what does it mean when I say get major? What does that mean? Does it mean that I need to go and do a query that retrieves the major for the ID of this student with the foreign key and primary key and go fetch it right away? Is that what it means? That I go fetch, or does it mean that when I instantiate the student instance object, that I join with the major table and I populate this object instance, and then I also join with the enrollment table and fetch all the enrollments and I provide this list of enrollments here? Is that what it means? Notice that it would be very, very expensive if I ask for 1,000 students and I have 1,000 instances, and each instance has an instance of the department. Right? That'd be very expensive. And that each student would have instances of all the enrollments also in the objects. Right? That'd be very, very expensive to do. All right? So typically, we would have to decide, well, do you want to instantiate that right away? Or maybe you want to postpone that at a later time when you actually need the information. Right? Meaning, do you want to be eager and fetch all that data now at instantiation time? Or do you want to be lazy, right, and retrieve that information on demand? You see that? Right? Because representing this in a database, when you do joins and whatnot, it's a very common thing to do, of doing all these joins at the relational database. But transferring that same capability over to an object-oriented world is completely different. Because one is dealing with thousands of records at any one moment, whereas the Java code is running with a very small snapshot, a very small subset of the actual data set. Does that make sense? So you have to use completely different considerations here. All right? So typically what we would do is perhaps instantiate the major department and maybe provide that instance here, right? Probably it'd be one single instance that could be shared amongst all the students in the department, as opposed to having multiple instances of this department copied over and over for all the students. Yes? And probably the enrollments, we won't be loading those enrollments until we actually need them. So probably one will be eager, whereas the other one might be lazy, right? And so again, those implementation details matter, right? Same thing when you are instantiating a department. What does it mean when you're instantiating a department? Do you just want the name of the department? Is that all you need? All you want? But something that it would be very reasonable in a relational database of saying, well, here's the department. I want the students that are in this department. Okay, that's a very reasonable query in SQL. But in Java, what would that mean? Do you mean that when you get the instance of the department, you're also going to instantiate all 1,000 students that are in that department and load them up, even though you might not even need them? Okay. So again, here too, you would decide that perhaps there should be a lazy load, right? I load that data on demand. Only when you ask the get question, then I would use a connection to go fetch all that. And even then, I would only give you a subset of those students. Only when you ask for more students, I would go fetch more students, right? I wouldn't actually load all 1,000 students. That makes no sense. So maybe the courses, we might say that it's eager, but the students might be something that would be done lazily. Make sense? All right. So let's another thing here. Notice that there are no notion of foreign keys and primary keys. All right, that is completely lost. Right, those are foreign keys and primary keys are an artifact of how relational databases maintain associations. Right, it's not really part of the data. Right. It's only an artifact that is used in relational databases to maintain relationships between records. Right? It's not really part of the data. Even the get ID here as part of the model is somewhat skeptic that we even need it, right? Especially if we know that students and sections and those relationships together make it unique, or this department ID is also somewhat suspect. Perhaps the name is uniquely identifiable, right? In object orientation, the instance of the object is enough for identity. Right? This is represented only once in memory as a pointer. Right? Obviously, it's its own identity. Right? We don't have having a unique identifier is redundant. Right? Of a way of uniquely identifying this object. Any object, per definition, is uniquely identified. Anyway, let's jump to source code, and let's code some of this so you get a notion of of how you would implement some of this. All right, let's do that.